Trinity College in Dublin in 1944 called What is Life? So I wanted to talk from his podium, which I did, and it's on my website. There's this video of my talk, and my title was The Plasticity of Human Aging. When we were kids, we all looked like Winston Churchill. But as we get old, we look very different. So the heterogeneity of old people is manifest. That is codified through the second law of thermodynamics. But my friend Freeman Dyson, who has Einstein's chair at Princeton, followed up on it and said, it's not the origin of life, it's origins too. He bifurcates the definition into metabolism and replication. So he says it really is two phenomena. One is kind of how the engine is running, the other is how does it assure replication. So this is my effort to take Freeman Dyson into energy and replication over time. Now, time is the important element that has not been recognized or identified. Time, because time goes on. We cannot put it into a formula because we don't know about it. This graph is critical to all of us. This is the Eastern effort to replicate Tao. Yin-yang, the organism and the environment, and it's black and white, but it's wrong. Because the critical thing is the interface. And I've got a graphic designer grandson who I'm trying to get to redraw that for me. Showing between the black and the white is this gray zone. Everything's what's happening epigenetically. Maybe the white side, the genes, the bones, and the rest of it. What's happening, the critical part is what's happening in the gray zone between. Now all of this comes current because some of you will know the term GWAS, G-W-A-S, Genome-Wide Association Studies. And there have been hundreds of millions, if not billions of dollars spent in the medical emporium looking for the gene for baldness, for homosexuality, for compulsion. Everyone wants a gene because if they get it, that's not only a Nobel Prize, it's bucks. So GWAS has occupied virtually the entirety of the medical investigative world. I've nurtured a young guy at Stanford, who I had dinner with here 2 nights ago, Patel. And he said, it ain't GWAS, it's EWAS. EWAS, Environment-Wide Associated. It's not where the gene is, it's how it's reflecting on its environment. So back to my town there. So I was giving the kind of musing on this, and I was giving a talk at the Fairmont in San Francisco, and a guy put his hand up and said, have you heard of Prigogine? I said, who the hell is he? Prigogine was a Belgian physicist who won a Nobel Prize in '77 for explicating the second law of thermodynamics. And his book is one of the epiphanies of my life, because it explained why my leg in a cast grew old. It said all matter conforms to a pattern rendered coherent by an energy flow. So the Earth is interposed between the sun and space. And as that solar energy traverses the Earth, it sets up cycles. We're a cycle. We are, in Prigogine's terms, a dissipative structure. We're a bunch of carbon and hydrogen and oxygen and nitrogen, all rendered temporarily coherent by this drive of energy. My leg grew old in a cast because it was taken out of an energy flow and it dissipated. So we all are here temporarily as a dissipative structure. Now this is the critical slide. It shows how we become what we do. It's the conversion of energy to structure. One of my favorite moments happened here at a talk I was giving in Harvard. I don't know, it was here. But a woman put her hand up and said, "Doctor, you're going to love this." He says, "You know, if who you are is what you do, when you don't, you aren't." Now, ponder that. If who you are is a reflection of the energetic stimuli working on your structure, when you don't do anything, then you go to hell. Right? So that is all enabled by this transposition of solar energy through these molecules, shaping them as they traverse our carcass, eventually going out to space where all energy ends up. Anyhow, momentarily residing in this carcass that becomes what we do. Now that all happens by what are known as receptor sites. A receptor site is a protein molecule that sits on the surface of every one of our 100 trillion cells. We have more cells than there are stars in the firmament. So we're incredibly complex. So these receptor sites are listening, hearing. You're seeing me because your retina has receptor sites that are catching the photons that are bouncing off of me, going through your pupil, back your optic nerve to your occipital lobe where you're seeing me. You're hearing me because of the receptor sites on your tympanic membrane are hearing the vibrations of my voice and going the same routing. So we are nothing more than an organization of these protein molecules internalizing the environment and shaping us in precise byproduct to this. This is an effort to show you how complicated it is. This is a cell. This is a Drosophila cell. Every one of those dots is a protein molecule. And they're all talking to one another under the influence of genes, which are like switches, on and off and on and off. But not just on and off, but rheostatic. A little bit on, a little bit off. So it is so incredibly complex and so uncertain as to make it impossible to think that we're ever going to find a magic bullet. Because it's the process, it's the dynamics. One of my closest friends is a guy by the name of Eugene Yates, Y-A-T-S at UCLA. And I wrote a paper called The Physics of Frailty, and he reviewed it, and I said, "Who the hell are you?" He then told me, he was his physician, he wrote a paper called Homeodynamics. Now you all, I know homeostasis, because Walter Cannon up here, who taught my father physiology, coined the term homeostasis. Goes back to Claude Bernard. Why are we so stable in this mixed up world? Gene Yates says there's no homeostasis. Stasis is alien to life. All life is dynamic, so his word is homeodynamics. So this portrait that I gave you a bit ago. Here's a paper that my son, Dr. Walter Bortz IV, and I wrote, showed how fast do we age. This is VO2 max. Most of those lines are athletic performances in them, running, swimming, biking. But the strong line up top is VO2 max in fit people. The lower line is VO2 max in unfit people. Now you see then that the athletic performance coincides specifically to VO2 max. So it is our ultimate biomarker for fitness. And that showed that we've seen several times Steve Blair's figure. This is a restatement of Steve Blair's data. Physical fitness and all-cause mortality, a 30-year age offset. A fit person of 70 is biologically the same as an unfit person of 30. I had my VO2 max measured by Maria Fiataroni in Sydney, Australia a few years ago, and I got off, and she said, "Walter, you're 40. I said, "I know." Because all of my gene switches were tuned to a fitness level, and I'll demonstrate that to you. Well, here's my disuse and aging paper. And I updated it a few years ago, saying time is a cost. And here is reflecting to Mr. Q. So on the left is what we got, and it's where we've been, and it's all wrong, because it's a new world. And Aristotle said that the whole is much more than the sum of its parts. So as we've taken apart this organism, this dissipative structure of ours, down to the atomic level, we know every atom of our bodies. You say, so what? Because that's not very important. It's how the whole works. It's not the components, it's the system. It's not the present, it's the process. So this is the critical replacement era that we're in now. And it all comes down to energy. Thermodynamics, solar energy temporarily traversing our bodies, being changed into structure and various things. And this is what it looks like on a graph. And you see that there is an optimum. And that optimum corresponds to the Greek golden mean. Aristotle said nothing, not too much, not too little, just enough. So if you're trying to get by with too little, which is disuse, which is the left side of this, that's bad. But there's also too much energy, and that's stress. How many RPMs go through this carcass? So there has to be the appropriate number. And here's the Greek golden mean, and it transcribes exactly to health. Health exists at the... Now there's a new term, and I think very few of us know this term, but I learned it 3 or 4 or 5 years ago. I had a guy by the name of Jared Diamond come up to speak at my group. Jared wrote a great book, Guns, Germs, and Steel, and he's a UCLA type. And whenever I have a guest, I always kind of look up what they've been up to, and I looked on PubMed, and Jared Diamond had written an article about symmorphosis. I said, holy God, what an ugly word that is. But symmorphosis says that whenever you have a process of multiple stages, like oxygen delivery, like caloric, every single step in that transport system must quantify precisely. If it didn't, then there would be a bottleneck. But as we're moving oxygen from there to our mitochondria, every step, heart, vascular, membrane, mitochondria, they're all precisely quantified. Scaling is the